Hi children, welcome to my YouTube channel. Today our topic is energy resources and energy transfer part 2. In this topic we are going to discuss about Sankey diagrams. What is a Sankey diagram? A Sankey diagram is a type of a flow diagram of energy of a device or a system in which the width of arrow is proportional to the flow rate. Let's try to understand this Sankey diagram from a simple way. If you get this example, we have provided electrical energy of 100 joules to a device, right? Out of this 100 joules, 10 joule converted into light energy and 90 joule converted into heat energy. Then when you draw this Sankey diagram, this width must be proportional to the amount of energy we supply and amount of energy output as a production, right? Then when you draw this, you draw a little bit of a width, a line with kind of a width which is proportional to 100 joule. Then compare to this 100 joule, the energy conversion of light is 10 joules. So in that case, we have to draw a line which is proportional to 1/10 of this width. You not should draw exactly when you are having in kind of examinations, but it should be kind of you have to show some kind of a proportional to this energy ratio when you draw a Sankey diagram. Not the exact amount, but it's better if you can draw it in a way which represent the energy in a proportional way. And you can understand that here the width is should be proportional to 90 joules. So you can take a, for example, if you take 10 centimeters over here at the width, you can mark 1 centimeter width over here and 90 centimeter width over here. That kind of proportionality should be shown in a drawing a Sankey diagram. The simple idea of the Sankey diagram is it's an energy flow. It's a diagram which shows the energy flow in a way of different energy productions in a device or a system. Let's try to understand more about Sankey diagram in this example. In a filament bulb of 100 watts, 90% of energy wastes as heat and rest as light. Draw a Sankey diagram for an operation of a bulb for 1 second. We know that 100 watt. What do you mean by 100 watt? That means it consumes 100 joules in 1 second. So if you operate for 1 second, it has 100 joules. Out of this 100 joule, 90% waste as heat. So amount of heat energy would be 90% of 100 joules. Therefore, the amount of heat would be 90 joules. And rest, 90% of energy waste as heat means 10% would be converted into light. So therefore, 10% of 100 joules should be 10 joule. Then the input is 100 joules. Output would be two operational formats, heat energy of 90 joules and light energy which produces 10 joules in that. So when you draw a line, the width of this line should be kind of proportional to 100, 10 and 90. For example, when you draw it 10 centimeters over here, you can draw 9 centimeters and 1 centimeter over here as I mentioned in the previous example. The second example, right? In a gasoline internal combustion engine, this word is kind of big, but that's simpler idea of a fuel engine, right? 40% of energy waste as exhaust gas, 30% as coolant, 5% as friction. Draw the Sankey diagram to represent above information. If you add these percentages, see whether how much you get. 40, 30 plus 5, it's 75. So what happened to the rest of the 25? This rest of 25 is the effective energy, effective power of this energy, energy from this combustion engine. Rest of the energy waste as different formats of as in exhaust gas, coolant, and friction, etc. Right? Okay. Then 25% will be useful energy. So 100% over here, 25% over here, 5% over here, 30% over here, and 40% over here. So when you draw it, when you draw the widths of this line, it should be proportional to 100, 25, 5, 30, and 40. This is a way of drawing a Sankey diagram for this given information. Right? The best thing we have to understand about when you draw in the Sankey diagram is when you draw it, it has to be, we have to consider the width of this line as proportional according to the given format. Sometimes the question may be given in the amount of energy, like 100 joules, 10 and 90 joules. But certain question they might given as percentages. Whatever the way, we are using the same technique to draw the Sankey diagram. Okay. In this example, in an electric hair dryer, out of the electric energy input 125 joules, waste as kinetic energy and 150 joules as sound in dryer fan. Draw the Sankey diagram to represent this information. Here they haven't given us what is the initial amount. We will mark that initial amount. Right. It should be out of 750 joules. Right. Let's back to the right. In an electrical hair dryer, out of 75 joules, in the electrical energy, the input 125 joules, waste as kinetic energy, and 150 as sound in dryer fan. Draw the Sankey diagram to represent. So initial input is 750, 125 waste as kinetic energy, and 150 as sound. So the rest is how much? Rest is 550. So you can draw the Sankey diagram which is proportional of 750, 125, 150, and 550. When you draw it, if you can draw it in exact proportion of 750 to 125 to 150 to 550 is much better, but manually when you draw it in a way of representing in a 750 with the general length, and proportionally we can mark the widths of these arrows to the 125 to 150 to 550. That's a way of drawing a Sankey diagram for this electric hair dryer. Okay, let's come up with this question. In an electric kettle of 100 watts, 75% of energy converts as light and rest as heat. Draw a Sankey diagram to represent the information operation for a 1 second. Right. Draw a Sankey diagram for the operation of electric diagram for 1 second. Right. Okay. Then this is 100 watts operate for 1 second means the energy production is 100 joules. So therefore input energy should be 100 joules. Out of 100 joules, 75% converts as light. So light is 75 joules. Rest. What the rest of the amount? 25% of 100 joules, that is 25 joules. So when you draw this, these which should be kind of proportional to the ratio of 100 joules to 75 joules to 25 joules. So you have to draw the Sankey diagram accordingly. Right. This is another example. In a petrol engine, 75% of energy waste as heat and rest converts into kinetic energy. So, say out of 100%, 70% converts into heat means rest of would be 30%. So, input is 100, 70% waste and 30% as kinetic energy. That is the Sankey diagram which represents this information in this question. Right. An electric fan out of 750 joules of input energy, 600 joules converts as kinetic energy. So you know that input energy is 750, kinetic energy of the fan is 600. So what would be the rest? If you subtract 600 out of 750, the remaining is 150. That is the conversion of sound and thermal energy of an electric fan. So you can mark the Sankey diagram according to the information given over here, right? So that is a basic concept of drawing a Sankey diagram. Hope you have understood the contents in this video. If you like this video, put a thumbs up and share this video with your friends. And to watch my educational videos, please subscribe my channel and click on the bell icon. Thank you and see you from next videos.